Hey guys, here's the answer key for your district assessment review. This isn't quite as nice as the videos as you've been watching, but I'm going to do my best, okay? So, all right, here's the stuff that you need to know for safety. First thing you should know are these three symbols. Obviously, the one with the flame represents something that's flammable. This symbol here will represent something that's radioactive. And then this looks like a little liquid that's falling on either somebody's hand or on a surface. And it shows that it's kind of eating away at it. Well, that's what we call corrosive, something that's going to eat away at another material. Okay, MSDS, we need to know that that stands for Material Safety Data Sheet. And every chemical will have its own MSDS, everything from soap to acid to whatever, okay? In the hazard diamond, you do need to know the location of the colors. So on the left is blue, top is red, the right-hand side is yellow. And what those stand for, red is fire hazard, blue is health hazard, yellow stands for reactivity, and then this bottom square or this bottom diamond is a white diamond. And that's where we would put any special hazards that we should consider for that chemical. All right, now what do the numbers mean? Now, again, notice I didn't put any numbers in my diamond. That's because this is just a representative one, okay? Again, all elements, all compounds, all materials are gonna have their own MSDS. But what you should look out for are the numbers. Now, the number 0 tells me that this chemical is not hazardous at all. It's not very harmful. The 4, on the other hand, tells me that it is very dangerous and we need to watch out for it. Okay. Safety equipment, if you get a chemical in your eye, we use the eye wash. We're going to use that for at least 15 minutes, okay? And yes, you have to keep your eyes open. We want to get all of that chemical out. Part B, always wear an apron and goggles for all lab experiments. C, this one should go without saying, all accidents, no matter how big or small, should be reported. All right, part 2, matter. These can be found on pages 10 through 13 of your notebook, and also the lab that we did for matter, okay? Pure substances versus mixtures, you definitely have to know this diagram, okay? It may actually even just show up like that, so please know it. Matter is divided into 2 main categories. Now, what divides them is whether they are variable composition or the same composition. What does variable mean? That just simply means that there's different components. All right, so if the answer is yes, that the matter is different components, then we follow this way and we call it a mixture. There's 2 further subcategories of mixtures, and those include something that is uniform is homogeneous, and something that is not uniform is heterogeneous. So for a homogeneous mixture, you would be able to see distinct parts. Like, let's say this part was solid and then this part had little, pieces in it or whatever, okay? So there would have to be some kind of distinct look that made it different. Oh, you know what? I just totally told you that wrong. Oops, scratch that, move it over here. Okay. Heterogeneous is the one where we're going to have visibly different parts. So you can see that in this container, the top part of the container is different from the bottom of the container. The other one, homogeneous, sorry about that, is going to be the same throughout. So it all looks basically the same. Okay? All right, now moving over to the other side of this diagram, let's say that the matter we're inspecting is not a variable composition, meaning it is the same throughout. Well, then we would call it a pure substance, okay? If you're able to separate the pure substance into simpler substances, if the answer to that is yes, then what you have is a compound. If you cannot further divide it, then what you have is an element, okay? Please know this diagram. Okay, over for what is a homogeneous liquid. That's also called a solution. Again, it's just a term that you need to be familiar with. All right, so then classification here. Aluminum is a pure substance. We find it on the periodic table, so it's an element. Apple juice is not on the periodic table, so we do not call it a pure substance. It is a mixture. It has water, vitamins, sugar, a whole bunch of different stuff in it, okay? And so since it's a mixture, it's neither an element or a compound, so this is kind of misleading. It would, however, be homogeneous. Okay, hydrogen peroxide, the chemical formula for that is H2O2, and as long as that's all that's in the container, then we would call it a pure substance. Since it's made up of hydrogen and oxygen, it's a compound. Okay, chicken soup, that should be obvious, that is a mixture. And again, it is not a type of element or a compound, but when I look at it, it's definitely heterogeneous. Okay. All right, in this next set, water is a pure substance as long as all that you have is pure H2O, and H2O would be considered a compound. Coffee is a mixture, and if you make it correctly, hopefully it's going to be homogeneous. Okay. Ice, again, as long as it's pure water, we would make it a pure substance, and that would be a compound. Carbon is a pure substance, which would be an element. Again, because it's found on the periodic table. Okay, methods for separating mixtures. We have 3 that you need to know: filtration, distillation, and evaporation. Filtration is going to be used for separating a solid and a liquid. Our example is sand and water. Distillation is a method of basically like evaporation, but in a very controlled way, so that we can separate a mixture of liquids. So if you imagine you have like rubbing alcohol or acetone dissolved in water, you would want to control the boiling point of it, and that's what would allow the alcohol or acetone to evaporate off quicker, leaving you only with the water. Okay, evaporation is what we're going to use to separate a mixture of a dissolved solid, like salt, in a liquid, like in water. Okay, all right, part C. This one's asking us to do 2 things. It's just like up here, where we want to identify pure substance or mixture, and classify pure substances as elements or compounds, and mixtures as homogeneous or heterogeneous. In this picture, we can tell that that's a pure substance. It only has one type of like little picture there. It's definitely an element because they're all the same. And we can actually tell something else from this picture. We can tell that this is a solid. Okay, I know that's not what the question was asking, but you should be able to tell me that that's a solid. All right, this next one, notice that we have different components. We have this big glob right here, and we have little smaller molecules. So since within the container there are different things, I know that it's a mixture. I can also tell that it's homogeneous because it's pretty well evenly spread out. Like up here, there would have to be a very distinct part of the container where there's a difference that can be seen. Okay, so maybe if all the big blobs were on one side of the container and all of the little molecules were on the other side. Okay, so that's going to be homogeneous. This next one, it's hard to see, but there are darker atoms in the middle. So we have the light atoms and the dark atoms. That's going to be a pure substance because each of these is identical, but individually we're going to call them compounds. Okay, same thing over here, same idea. We have one individual cluster is going to be called a compound, and since it's the same compound within the container, we call it a pure substance. All right, that does it for page 1. Please watch video 2.